Hi, welcome to episode 1 of Physiology 101 series, where storytelling meets medicine. So the other day I was just recalling all the memories from my medical college. Do you remember in physiology practicals, they used to give us these lancets and we were supposed to prick ourselves, you know, draw some blood and, we were supposed to look it under the microscope. It was painful. I don't really remember when we did this experiment, but we were supposed to measure our own erythrocyte sedimentation rate. So today's episode is going to be about the acute phase reactants. So ESR, erythrocyte sedimentation rate, and CRP, C-reactive proteins, are two of the most commonly measured acute phase reactants in medicine practice. But not many people understand how they work. We have all measured erythrocyte sedimentation rate, where we take a fixed amount of blood within a test tube, chelated with sodium citrate, and we see the settling down from the top, how much of the red blood cells have settled in an hour. We measure the distance in millimeter per hour. This is called Westergren method. But due to the paucity of time in the current day and scenarios, we have these newer machines which centrifuge the blood and give us result within 5 minutes. The RBCs are negatively charged cells and they usually repel each other. They don't want to settle together. But in the presence of certain positively charged large proteins like fibrinogen or IgG, they sort of come together, gel together and settle down. So any inflammation or any scenarios where the fibrinogen or IgG levels are high, ESR will be high. And ESR takes a while to settle down. After the settling down of inflammation, ESR will still stay high for a while, for at least a few weeks, because the half-life of fibrinogen is around 100 hours and the half-life of IgG is around 7 days. It takes a while for the ESR to settle down. There can be some false alarms while measuring ESRs. Like in the case of anemia, when the number of RBCs are low, plasma flows up, so ESR increases. And in the cases of polycythemia, there are high number of RBCs which repel each other and settle down slower. So ESR is falsely low. Whenever we give IgG, like in case of Kawasaki, because of increase in IgG levels, ESR will be elevated even after the inflammation has settled. And in the cases where fibrogen is low, hypofibrinogenemia, ESR will be falsely low. Coming to CRP, CRP was discovered in 1930s in the cases of pneumococcal pneumonia. This protein precipitated with C polysaccharide antigen of pneumococcal cell wall, hence the name C-reactive protein. Earlier, CRP was measured by a Quelling reaction, so it was only qualitative, present or absent. But now we have quantitative assays which measure CRP in milligram per deciliter or milligram per liter. CRP is a protein which is synthesized in the liver. So whenever there is hepatic injury or liver failure, it will be falsely downregulated or it will be falsely low. Liver increases synthesis of CRP within 4 hours of inflammation of acute injury, and it doubles every 8 hours, by reaching peak around 36 to 52 hours. And half-life is only 4 to 7 hours. So after the inflammation has ebbed, it falls down more quickly than ESR. So it is a good marker for acute inflammation. Now coming to the main point, there is something called ESR-CRP ratio. Since ESR takes a while to settle down and CRP settles down way quicker, the ESR-CRP ratio can give us insight into whether the inflammation is chronic or acute. So whenever ESR-CRP ratio is more than 15, where numerator is higher and the denominator is low, means ESR is high but CRP is low, it usually indicates it's a chronic inflammation. So ESR-CRP ratio of more than 15 is indicative of rheumatological diseases or autoimmune diseases, while an ESR-CRP ratio of less than 2, where ESR is low and CRP is high, acute inflammation, is usually indicative of infections, acute infections. I hope you find this video useful. Please feel free to share it with your colleagues and your friends so that they can join in this journey of storytelling and medicine. And hope you enjoy and have a good day and keep learning.